with all of the test information that we'll review. Okay, and please jump in and stop me if you have questions at any point. Okay, so for number one, cognitive psychology deals with how, and the answer is all of the above, right? We know that it's about how humans gain knowledge, how we process information, and also how we store information. Number two, the answer is A, rationalism is the idea that knowledge comes to us through our reasoning abilities, and also sees the human mind as being active. Number three, the mind as information processor was a central feature of actually none of the above. So remember, in behaviorism, there's the idea of, well, there isn't a mind. It's sort of this inaccessible little black box. We can't study mind. All we can study is behavior. Gestalt psychology wasn't seeing mind as information processor per se, but more as a meaning-making entity. And then with functionalism, the emphasis here was on the ways in which our cognition plays out. And so the mind as information processor, this was a central feature of the information processing, or more of the computational approaches. So for number four, the contributions of neuropsych and cognitive neuroscience are important because they can give us confirmation about what the cognitive models that are more theoretical and abstract in nature are able to predict. So it's kind of like neuropsych and cognitive neuroscience. They sort of are like opening up the hood, and we can see underneath all of the different parts that can help us better understand our behavior, our choices, things like that. Okay, contributions of previous psychologies to cognitive psych, there were a lot. And so because of that, it's all of the above, right? We have William James, who was pretty instrumental in the idea of consciousness. We have Wilhelm Wundt, who was a big name in psychophysics. I can't speak. That's not good. Psychophysics. And so being able to sort of quantify how consciousness happens. And then, of course, we know that the Gestalt psychologists were foundational to cognitive psychology as well. Number six, Ebbinghouse's nonsense syllable experiments. These were looking at learning and memory specifically. It wasn't involving any of these other processes in terms of their specific focus. Number seven, the important forces behind the cognitive revolution were a lot. And so we did see sort of this idea of this failure of behaviorism, wasn't able to account for everything. And also the emergence of this idea of behind communication theory. We had linguistics in there. Specifically, we talked about Noam Chomsky really just ripping into Skinner's explanation about language. And then we also had the development of computer science and other technological advances as well during that time. Computers that helped us to have better, more accurate methodology when it came to measuring human cognition. So for seven, it's D, all of the above. For number eight, behaviorism and cognitive psychology clash on which of the following principles? So as you remember, they clashed on a lot. And so here, the right answer is B and C. The experimental method was actually one of the few things that these two schools of psychology agreed on. Whereas behaviorism said, well, mental events aren't a thing. We can't study them. They don't exist. It's, again, all about behavioral responses to stimuli in the environment. And then they also disagreed on the use of animals, whereas behaviorism said, hey, you know, humans are animals, and humans are pretty mechanistic in the way that they respond. Therefore, studying a rat should give us the exact same sort of information that it would if we studied it in a human. Whereas cognitive psychology said, no, no way. Humans are distinct from other animals. So number 9, cognitive psych is based on which of the following assumptions? And the answers there are A and C. Again, it wouldn't be B because that is an assumption of behaviorism, which we know psychology didn't take much from, or cognitive psychology didn't take much from. Okay, and so imaging techniques, ones that are static, like CT exams, right, which is, again, this idea of static, you're just taking this snapshot in time. And also dynamic images like fMRI, where you're able to sort of see activity happening in real time. Using both of those techniques, we can look at both the structure and the function of the brain. If we were looking at just static imaging techniques, so CT, MRI, that would just give us a sense of the structure of the brain. If we were using just dynamic imaging techniques like fMRI or PET scans, that would give us just the function. So the combination of them together gives us a lot more robust of a picture of what's going on in the brain in terms of how it's organized physically and also how it functions. Okay, number 11, looking at the breakdowns in cognitive functioning that happen due to brain damage, this has resulted in helpful information about normal cognitive functioning. It essentially allows us to sort of fill in the gap. I like to think about how brain damage informs our understanding of normal functioning with like the analogy of a car. You might not know all the ins and outs of a car, but you get a much better idea of how it normally functions when something breaks down. You know, if you don't fill up your gas tank, right, you're like, oh, my car won't run because normally it needs to have gas in there. You know, you go to start your car and it's like, you take it to a mechanic and they tell you about, there's this part called a starter. And you're like, oh, I didn't know that. But now because of that breakdown, you can understand, oh, well, normally when I do this, it activates the starter. And I'm not very much of a car person, so I can't tell you more than that in this metaphor. But that's the way that I like to think about it. And so again, because of that, that's going to rule out options B and D. Unfortunately, for C, brain damage, it still happens. It's still a possibility in our world. Even though we have really come very far in terms of the kinds of technology that we have to try to keep ourselves safe, right? You know, really sophisticated airbags in cars, and now we know how important it is to wear a helmet and things like that. But brain damage still does occur. Okay, so for number 12, all of these are our methodological approaches that we talked about. So postmortem studies, so, you know, being able to examine somebody's body and brain after death, using the animal studies to give us sort of a general sense of how cognition happens, just in terms of like in the animal world, and then also with neuroimaging as well. And so for number 13, so one of the weaknesses in template matching theory, if you remember, is this idea of there's this 1-to-1 ratio of every time you see a letter A, you store that one instance. And so the issue here is the idea of just countless templates, right? If you think about all of the variations in fonts, and then you add in the idea of like, right, like reading people's handwriting too, that's like its whole other set of sort of fonts, so to speak. And so because there's this idea that there are countless templates, it doesn't really explain how we're able to efficiently and quickly respond to objects that we see. Okay, and then for 14, an advantage of the feature analysis theory is that here, again, you'll remember that feature analysis kind of grew out of the critiques of template matching. And so here, feature analysis was really looking at this critique of, well, there are so many templates that you can look at, and was able to really narrow it down and become more efficient in its proposal of how we go about perceiving the world. Because here it says, well, there are only so many features that you can look at. You know, there's only so much to a shape that you can assess. Round, you know, its shape, its color, how heavy it is, things like that. There's only so much that you can store, and therefore you're a little bit more efficient because of that, at least in comparison to template theory. And then 15, so overall problems that run throughout prototype, template, and feature analysis theory is that none of them are able to account for top-down processing, right? You might remember we talked about they all can tell us from a bottom up, from more of a constructivist model, how we go about perceiving the world, but they can't account for our top-down processing, our inferences and our assumptions, and our ability to pull on previous memories and experiences. Oh, I jumped too far. Okay, number 16, Melanie's visual system can sense all parts, but when asked to identify an object, she can only identify certain parts of that object. I changed this on my end, but you all had A, visual agnosia, and D, visual agnosia. So my bad on that one. My visual system was having some difficulties, I guess, when I was typing this question. So regardless of if you put A or D, if it said visual agnosia, I gave you points for that. Number 17, agnosias may involve the loss of ability to recognize objects through all of these modalities. Remember that agnosias is just sort of the broad word for a loss of perceptual ability. And this can happen because of an agnosia in our tactile system, being able to touch, sight, seeing faces specifically. And so again, based on this idea of agnosias for number 18, agnosias can show us what happens when people aren't able to integrate, to bring together the elements of their perceptions. And so it doesn't provide evidence that just the visual sensory system is damaged, because agnosias, again, they can happen in any of the sensory systems. It's not just limited to vision. And it's not information processing that's sufficient, and they certainly don't show that the brain can't be damaged, because they are a direct result of brain damage. Number 19, all of these tasks have been used to study attention experimentally. That's why the answer is D, all of the above. For number 20, you'll remember that there were differences between Broadbent's attentional model as well as some other attentional models in terms of when the filtering, when the selection of information happens when we are attending to something. And the differences here was that Broadbent's attention model had an early filter. So this filter kicked on a lot earlier in the attention process than did these other filters as proposed by Deutsch and Deutsch as well as Norman. So for number 21, the dorsal, wow, that's a new one. The dorsal pathway processes where information is, while the ventral pathway processes what information is. And so again, this was the little mnemonic that I threw out there of how at least I help myself keep these straight in my mind. I think of dorsal begins with D, donde in Spanish begins with D, donde means where, so dorsal, donde, where, okay. And so those are the distinctions between the dorsal and the ventral pathway. So for number 22, capacity and resource theories, they actually involve all of these options that are listed here. So they're described by all of the above. In both of these theories, they see attention as really limited. We can only give or pay so much attention at any one time. They also see this sort of conceptual filter that's involved in our attention. And they also were developed to help account for sort of the idea of our selective attention. Why are we able to focus in on certain aspects of a task or certain aspects of what we're looking at or the information that is coming into us? And the idea is that we're able to modulate our attention so that we can select something specific to focus on. So for number 23, in divided attention studies, there was evidence that tasks could become more automatic. So this idea of this sort of practice effect, so that you can think about learning how to drive a car, right? Where you first had to learn how to drive a car, it felt like every single task that you did was just like, took all of your attention, right? Like 100% of your attention went into pressing the accelerator, 100% of your attention went to checking your mirrors, to turning on the windshield wipers. But eventually with practice, because you're able to divide your attention, and because the mind has these more efficient ways of using our attention, we're able to automatize some of that. That's why we sort of, we have these experiences of sort of autopilot, right? If you've ever gotten in the car and driven somewhere and gotten to your destination and being like, I literally have no memory of driving here. Like, did I like obey the rules of the road? Like, was I speeding? Like, I wasn't attending to what I was doing, because there was this automaticity of that task as well, because you had practiced. Okay, and so for number 24, processing that has little to no attention, it's effortless, it really just happens all at once without you really thinking about it, is automatic. For 25, the results of the Stroop study are explained by this conflict between our automatic and our controlled processes. So if you remember, the Stroop effect or the Stroop studies involve these three separate stages. So the first stage or phase of the study is the person just has to name colors that are like blocks of color that are just printed off on the page. So like blue, red, green, red, red, blue, green. And then after that, they just have to read the words written out of those colors. So again, blue, red, green, red, red, etc. And then finally, the stage where we see the Stroop effect is when the person is instructed to not read what the word says, but say the name of the color that the word is printed in. And so we have this then conflict between our automatic process of reading and our controlled process of, well, I have to take these certain instructions. I have to focus actually on the color of the ink that this word is printed in. I can't just automatically blaze through it and just read the words that are on this page. And so that has been the proposal of why we have this Stroop effect, and why if you've ever taken a Stroop test, that it's so hard once you get to that that third phase, because there is this competition between your automatic reading abilities and your controlled abilities of, but there are instructions that I have to listen to and specifically pay attention to. Okay, so for number 26, sensory stores being modality specific, this means that there is one sensory store devoted to each of our senses. So we have a gustatory store, we have one for hearing, for smell, for taste, etc. Well, taste is the same as gustatory. Vision, we'll say, and so on. Okay, and for number 27, within the information processing theory idea of memory, forgetting is the result of both new information sort of writing over the old, as well as information decaying or fading away. So we have this idea of information is not sticking because it's just not being accessed, and over time it just fades away as a natural process of time. And then we also have this idea, right, of, well, information is just sort of being rewritten. It's being written over. For 28, echoic sensory memory is hearing. So it's kind of in the word there, echoes, right? You hear echoes. Whereas iconic memory or icons are things that you see, so vision. So A is the correct answer there. So 29, in magical number 7 plus or minus 2, George Miller, he started out with a mathematical model to try to understand short-term memory. And then he found that it actually didn't account for what he was seeing. And what he saw was B as well. He found that the number of items that can be held in our short-term memory are anything from 5 to 9. And then 30, the 4 components are of Baddeley Hitch's working memory model is the central executive, right? That's the CEO that's overseeing everything. We have the phonological loop, which is dedicated to auditory memory. We have the visual spatial sketch pad, which is devoted to visual memory. And then we have the episodic buffer, which is what is sort of combining or assimilating all of these different modalities of memory and then sending them into long-term memory. And is also, just combining those essentially. For those of you who are Office fans, I hope you liked my joke for D. If not, that's fine. I still thought it was funny. I laughed to myself when I wrote it. So yeah, so any questions on the multiple choice? Okay, I'm going to take that as a no. Just real quick, I'm just going to talk over what you could have written for each of the short answers. So for number 1, you could have talked about mind as associations, mind as brain, mind as network, structure, holistic, functional, rational, information processor, computational. And then within each of those categories, you could have talked about different things. So if you went with mind as associations, you could have talked about James Mills and this idea of sensation and association. You could have talked about his son, John Stuart Mill, and his idea about simple and complex ideas. If you went with brain, you could have talked about like archaeological evidence for brain damage. You could have talked about phrenology. If you did, though, you did need to note that phrenology turned out to actually be this problematic pseudoscience. And so it's, even though it sort of got the field going in terms of the idea of, there are certain aspects of who we are as people that are connected to parts of the brain, that really what has been important has been the field of neurology. Because neurology is not a pseudoscience, it's an actual science. If you went with brain as network, you could have talked about things like Hartley's vibrations, discovery of neurons, Bain's neural networks, William James's idea of neuronal arousal, Lashley and mass action, Hebb and equal potentiality. Mind as structure, you could have talked about structuralism, and also psychophysics and some of the associated names there, like Titchener and Wundt. Mind is holistic, Gestalt psychology. Mind is functional. You could have talked about the school of functionalism and talked about people like William James, or you could have talked about Pavlov or Ebbinghaus. Mind is rational. This was like the psycholinguistics area. So you could have talked about Noam Chomsky, for example, really criticizing Skinner. Mind is an information processor. This was like that World War II research with like planes and pilots and human factors. Also, you could have talked about radio systems. And then mind is computational. You could have talked about computers as analogies. You also could have talked about the emergence of artificial intelligence as well. So there are a lot of different directions that you could have gone in with that. For the second one, areas inside and outside of psychology that influence cognitive psych. So starting with areas inside, you could have talked about Ebbinghaus and verbal learning. And then you also would have wanted to talk about what it contributed, right? So cognitive psychology, they were like, well, we're not going to take this idea of fruitfulness, and we're not going to take this idea of like, oh, like it doesn't need to have ecological validity. You know, Ebbinghouse's study was interesting, but we don't store nonsense information, right? So his use of nonsense syllables was like, let's actually see what happens when we use meaningful information. And then you could have written about cognitive psychology accepting that human behavior was different from animals, and offers the use of the experimental method. You could have talked about other schools of psychology like structuralism, functionalism, Gestalt psychology. You could have talked about some of the things that those schools contributed and some of the things that cognitive psychologists said, nope, we're not going to take that. You could have talked about behaviorism, and we've kind of touched on in the multiple choice questions what cognitive psychology did and didn't take. You could have talked about the World War II stuff and the human factors. And then in terms of for areas outside of psych, you could have talked about information theory, and sort of the borrowing of terms from like World War II communication systems and like radios, and the fact that they have channels and filters and limited capacity. You could have talked about computers and computer science. You could have talked about the linguistics field and what that contributed. Yeah, so those are again some directions that you could have gone in. For mental processes, this one I think was pretty straightforward. You all did pretty well on this one. So you could have said things about mental processes being key to understanding behavior, that primary goal of psych is or cognitive psych is to understand human mental processes. Humans are active processors. What the scientific method brings to cognitive psychology in terms of studying mental events, and this idea of the focus on mental events and human, specifically cognition. For number 4, so in terms of 3 areas that support top-down processing, you also had a lot of options here. You could have talked about Gestalt psychology and some of its associated factors like figure-ground relationship, for example. You could have thrown out the word superiority effect or configural superiority effect. Could have talked about shape constancy as another piece of evidence. You could have talked about specific experiments like the gorilla basketball study. And then for number 4, you also needed to talk about how you need to address the second part of how do we reconcile the existence of both bottom-up and top-down processing. And so you needed to say something along the lines of the fact that if we went with just top-down processing, it would underestimate or not leave a lot of room for sensory information, and that the opposite would be true if we went with just bottom-up processing, that we wouldn't have any way to account for our experiences and our assumptions. So this idea that we need both, and how both of those can be brought together. Number 5, here, talking about attention, automaticity, you'd need to talk about the differences between controlled and automatic processing. You'd also need to discuss the relationship between attention and automaticity. So essentially answering the kinds of questions of, well, why does this relationship exist between our attentional processes and sort of our lack of attentional processes in automaticity, right? And also talking about how controlled and automatic processing interacts with each other, whether that's conflictual or not. And then number 6, there's a lot of different evidence you also could have gone with to answer this. Could have talked about Ebbinghaus and the primacy and recency effect. You could have talked about Sperling studies on iconic sensory store. Could have talked about the echoic sensory store studies. Could have talked about George Miller, his research, chunking. You could have talked about forgetting via decay or interference, or you could have talked about short-term memory codes as well. So I know that was a lot. Does anybody have any questions? Okay, if you do have questions that either come up later or you just don't feel comfortable bringing them up right now in class, it's totally fine. Please shoot me an email. But again, overall, I hope you all are really proud of yourselves. Again, the average was an A minus. So way to go. That was really great on your first test with your over Zoom class. Yeah, that's pretty impressive. So well done. Okay, so I'm going to stop sharing for just a moment, and then we will jump into the lecture for today.
I'm sorry, I have a question really quick.
Oh yeah, what's up, Madison?
I was just wondering if we were able, or if you could make it available on Canvas to see what we put for the essay part. Like, did you grade that? Like, did you give us feedback? That's what I'm looking for.
Yes, yeah, I did. And it was just more general feedback. I mean, if you got full points, I just sort of said like, good, great, excellent, something along those lines. If there were points that you missed, I did tell you what I was looking for specifically. And so hopefully that sort of provides an explanation for you. But yeah, if you, I tried to play around with it in the student view, but because the test student account didn't take a test, I was like, oh shoot, I can't actually see what this would look like for you all. But there should be a way where like if you go and view your submission for the test, and if you scroll down to the short answer part, I put comments on every single one of the short answers that you all gave. So hopefully that will give you some information as well that you can use moving forward. Yeah.
Okay, thank you.
Yeah, you're welcome. All right. Let's jump into lecture. Okay, so like I said, on Wednesday, we kind of ran out of time, so I'm just going to cover one of the last of the sort of classical models that I'm going to talk about, and then we're going to move on to talking about the topic of schemas and scripts. So with these ACT models, again, these came out of the movement away from like the sort of classical hierarchical models, and actually came around the time of the spreading activation theory. And so because of that, like other models, it has a lot of these shared features where it's the idea of connected nodes that are networks that become activated with the spreading activation. And so this model was proposed by John Anderson. It's called the adaptive control of thought model. That's what the ACT stands for. There are various versions. If you look it up, there's ACT, ACTR, all these different things. And so this was developed really specifically with the analogy of computers. And it's important to note that these models of semantic memory, they don't make the distinction between semantic memory and episodic memory like we have. It's just sort of all just one declarative memory concept. There aren't any subdivisions within it. However, within this model, there is still this idea of different memory systems. So there is working memory and declarative memory, and then non-declarative or procedural memory. And so Anderson, so his belief was that there are different kinds of nodes that exist within declarative memory. And in terms of procedural memory, his idea here was that information is represented and stored in procedural memory based on these production rules. And production rules are, they essentially specify a goal that's to be achieved, as well as the necessary conditions and actions that are needed for that goal to be met. So an example of this could be seen in the following scenario. So a typical college student could use the following production rule. Well, if the goal is to study actively and attentively, and one of the following, and a condition is met, let's say the noise level in the dorm is like way too loud, and another condition is met, the campus library is open, then there are certain actions that you take to meet that goal. So both of those conditions were met, it was really loud, and the library was open. The actions you would take would be to gather the things you need to study, go to the library, and then work there. So again, this idea of there are these specific goals that have certain conditions that need to be met, and then certain actions that need to be taken. And so the idea here is, well, that is how then memory is retrieved. And so these are a lot more complicated models. And so I'm just going to sort of glance over them. So the idea behind Anderson, or I guess the motivation behind Anderson making these models, was he wanted to have this, what he called theory of cognitive architecture. Essentially, he wanted to be able to outline, well, what are sort of the basic principles of operation? Again, kind of using this computer analogy. How can I sort of generally describe how the human mind works? Just like somebody who, was studying computer science. Well, how generally do computers tend to work? Regardless of the operating system, or the brand or the purpose. Like generally, how does this work? And so another nuance here that sort of sets it apart from other models is this idea of actually working memory being a part of declarative memory. So sort of falling under the purview of declarative memory. Here there are also production rules that are involved, just like in our procedural memory as well. And that when these production rules are used, that's how there are new nodes that are created in the networks of declarative memory. And so overall, I think the important takeaway here is that this is a very computer-based and also very activation-heavy model of human cognition. And so there's a lot of activity that is going on with the creation of new nodes, employing the use of goals and conditions and actions. There are a lot of pieces that are needed and a lot of different actions that are needed in order for our cognition to work, quote unquote. So that is just a brief overview of the ACT models. So now we're going to move on and we're going to talk about schemas and scripts. And the reason why we're going to talk about these is that the network models that we've been using, these sort of conceptual theoretical ideas, aren't the only way that cognitive psychologists talk about how our semantic memory is represented and organized. So where did my cursor go? There it is. And so there's a man in 1932, Sir Frederick Bartlett, what a name. He had published a book on remembering, and he had undertaken his own sort of studies, actually, interestingly enough, around the time of Ebbinghaus. But in contrast to Ebbinghaus, he wanted to look at human memory for meaningful information. So again, Ebbinghaus was the one who had like nonsense words, where the information that he was asking people to remember didn't have any sort of particular meaning to it. And Bartlett wanted to look at, well, what happens to meaningful information? How do we remember that? And so in order to do this, he presented participants with a lot of different kinds of stimuli. So he showed them pictures, he read them like prose and poetry, and he also had them read some Native American folk tales and legends. And he's most famous for one of the studies that looked at a folk tale called The War of the Ghosts. So I want you all just to sort of pretend that you're participants in Bartlett's study. I'm going to read this story off to you, and I want you to see how much of it you can remember. One night, two young men from Ugalek went down to the river to hunt seal, and while they were there, it became foggy and calm. Then they heard war cries, and they thought, maybe this is a war party. They escaped to the shore and hid behind a log. Now canoes came up, and they heard the noise of paddles and saw one canoe coming up to them. There were 5 men in the canoe, and they said, what do you think? We wish to take you along. We are going up the river to make war on the people. One of the young men said, I have no arrows. Arrows are in the canoe, they said. I will not go along. I might be killed. My relatives do not know where I have gone. But you, he said, turning to the other, may go with them. So one of the young men went, but the other returned home. And the warriors went on up the river to a town on the other side of Kalama. The people came down to the water, and they began to fight, and many were killed. But presently, the young man heard one of the warriors say, quick, let us go home. That Native American has been hit. Now he thought, oh, they are ghosts. He did not feel sick, but they said that he had been shot. So the canoes went back to Ugalak, and the young man went ashore to his house and made a fire. And he told everyone and said, behold, I accompanied the ghosts, and we went to fight. Many of our fellows were killed, and many of those who attacked us were killed. They said I was hit, and I do not feel sick. He told it all, and then he became quiet. When the sun rose, he fell down. Something black came out of his mouth. His face became distorted. The people jumped up and cried. He was dead. So if you are feeling kind of unsure about exactly what took place in the story, that's okay. We're eventually going to talk about some reasons why that might be. So for now, I'll just keep talking about Bartlett's study. So that was one of the Native American folk tales that participants heard. And then after presenting the story, Bartlett would test his participants using what's called the serial reproduction method. And so he would ask them to report their memory for the information in the story a number of different times. So starting at 15 minutes afterward, he would ask them, okay, tell me the story again. And then after another delay, he would say, tell me the story again, tell me the story again, tell me the story again. And this happened over months and years. And so even though this, the way that he did this, it wasn't very rigorous. It wasn't very, I guess, good or strong in its use of the scientific method. But it still gave us some really interesting information about how people's memories for meaningful information can change with the passage of time. So there were some interesting patterns that Bartlett found. So first, he found that people tended to leave out details like the names of towns and characters or specific actions or reactions of characters. There was also this pattern that when people were recalling the story, they ended up using the language that was more similar to theirs, so more modern and reflective of how they would speak in everyday conversations. And so because of this combination of there being certain details that were always sort of predictably left out, and then this rewording, the reproductions of the material became shorter and just more condensed, more concise every time they retold it. Another pattern was that that Bartlett found was that people actually added information to the stories. So, and these additions were often the result of inferences or assumptions. So, for example, the part in the story where I said that something black came out of the warrior's mouth, some of the participants took this to mean that there was a ghost, and that the villagers had seen a ghost in the story, and so that's what they would report. And so to explain these patterns of findings, Bartlett came to suggest that his participants were engaged in a process called effort after meaning. So they were essentially trying to find a way to make meaning out of what they had heard after the fact. And so he had borrowed this term called a schema, and he applied it. He defined it as this active organization of past reactions or past experiences, and that these can help guide our processing of information. And so here, if new information is presented that doesn't fit a certain schema that we have, then oftentimes we will change that. We'll modify that information so that it does eventually fit in that schema. And so this, again, goes to support the idea that we've been talking about ever since we've been exploring memory, that we don't remember things exactly as we experience them or exactly as we heard them, but rather that our memories are reconstructed. And schemas are part of one of the ways in which this reconstruction can happen. And so, so much of this reconstructive process is really automatic and unconscious. You know, we're not aware that as we retell a story, maybe we've added something in that wasn't actually there, or we've left something out, or we're actually using different language than what we originally heard. And so if you remember back to when we were talking about more of like our implicit memory, there's the study by Bransford and Frank, where they had given participants different sentences that had different numbers of concepts in them. So things like the ants were in the kitchen, the ants ate the jelly was sticky, things like this. And they found that the participants in this 1971 study said that they recalled having heard a sentence that actually had never been presented, but rather it was just a combination of the different concepts from the actual sentences that they had been presented. And so Bartlett's work, unfortunately, went sort of unnoticed and unappreciated until the cognitive revolution of the 50s and the 60s. And so today, when we use the word schema, we usually use it in reference to something that's larger than just an individual concept. And so schemata, which is the plural of schema, probably has something to do with how Latin words work. I don't know why we don't just use schemas, but schemata, they incorporate both general knowledge about the world and also specific information for particular events. And so a schema is, it's really just this large unit of organized information that is used for our memory representations and sort of gets pulled into our everyday experiences. So I'm going to talk a little bit more about schemata. Okay, so a study by Rummel, Hart, and Ortney. So they viewed schemata as sort of these building blocks of cognition. And the idea that they had is that, well, schemata are these packets of information, and they have certain parts to them. So each schema has these sort of fixed parts to it that have to be there in order for that schema to be applicable. But then there are other sorts of things that they call variables. They don't have to be in exactly that same form. So an example is our schema of a dog, right? So we know that a fixed part of that schema has to do with the fact that a dog has to be a mammal. Typically has 4 legs, although sometimes you see the tripod dogs or dogs with wheels, and it's really beautiful. And also that dogs have to be domesticated, right? At least the schema that we have of dogs. It's not like this like mangy, dingo out in the wild. It's a domesticated dog. And then there are these variables too that can come with our schema, but aren't so fixed. So we have things like the breed of the dog, the color, its name. And so these researchers, Just and Carpenter, they came up with this metaphor of a questionnaire. You can kind of think about like a questionnaire of like when you like go to the doctor or something, right? You have to fill in these certain aspects. You have this form that has a lot of the structure already there, and then you just need to put in the specific information. And so schemata can also indicate the relationships that we have between various pieces of information. So going back to our dog schema, so in order to have a dog, there are parts of the dog that need to be put together in a certain way. So, the tail and the legs and the tongue, the teeth, they all need to be put together in a certain way. If there was a creature that had 4 legs, but the 4 legs were coming out of its head, if it had a tail that was sticking out of its nose, if its tongue was on the underside of a belly, right? We wouldn't call that a dog. Like that would be this sort of monstrous looking sort of Frankenstein's monster of a dog, right? You wouldn't look at that and say, oh, well, it has all the parts of the dog, so it is a dog. It not only needs to have the parts, but they need to be organized in a certain way. They need to be relational to each other in a certain way. And schemata can also be connected to other schemata. This is a picture of one of my mom's dogs, Charlie. He is the best. He has a habit of thinking that he's much bigger than he actually is. So this is him lying in a dog bed meant for one of my mom's chihuahuas. So anyway, I'm going to use him to talk about this idea of connections to other schemata that we can have. So let's take my schema of a dog in the form of Charlie. That schema for Charlie is then connected to a larger schema for boxers, boxer dogs in general. And when I think of boxers, I don't just think of the boxers that are this brown color. I think they're called fawn, but there are brindle boxers, there are white boxers, there are black boxers, things like that. That then is connected to my schema for working dogs. So these bigger, stronger dogs that were bred for some sort of purpose. And then that is also then linked to my schemata for just dogs in general, right? Aside from working dogs, you have all sorts of other categories of dogs as well. And so I'm aware of the time, so that's all of the dog content that we will have for today. We'll pick up this lecture and we'll finish talking about schemas and schemata and scripts on Monday. So does anybody